Alright, in this video we will be going through examples using the math class. Now the math class contains methods that will allow you to perform a number of mathematical operations in your Java programs. For instance, when calculating exponential values, instead of typing out numbers explicitly, for instance 2 times 2 times 2 times 2 times 2 for 2 to the 5th power, you can use a method found in the math class to perform this operation in a more elegant manner, as we'll discuss in this video. Of course, 2 to the 5th doesn't take very long to type out, but say you're calculating something like 2 to the 100th power, using the math class you can perform this operation in a much more efficient way. Other useful tools we will cover in this video from the math class are methods for calculating values of sine, cosine, and tangent, methods for evaluating the value of irrational numbers like pi and e, as well as methods for calculating logarithmic functions. We'll begin by creating a new project. We'll go ahead and create a new class in the project folder. And in the first example, we will be referring to pi, which we know has a value of 3.14159 ... knowing that pi is a non-terminating number. Also, know that pi is equal to 180 degrees. Without thinking about that too much, let's set a double variable named cos 180 equal to math.cos. And inside parentheses, we will put math.pi. Now notice what we did here. We first called a method from the math class called cos. And the way we called this method was by typing math.cos. Math being the class name and cos being the method within the math class that we will be using. The cos method takes a parameter, which is the value we will be calculating the cosine of. And in this case, that value is going to be pi. Because the value of pi is non-terminating, it would be difficult to provide a Java program with an accurate value of pi, which is why the math class provides a way of referring to this value. And we do this by typing math.pi. One thing to pay attention to is the fact that methods within the math class are static methods, meaning the methods in the math class can be utilized in Java code without prior creation of an object. This will make more sense when we begin to create our own methods. Okay, next we will create another double variable and name it cos0. We will set this equal to math.cos, and in the parentheses we'll put 0. We'll print the values out. And if we run this program here, we'll see the expressions evaluate to -1 and 1. Let's try another example using sine. We'll create 2 more double variables. We'll set sine 90 equal to math.sine, and in the parentheses we'll put math.pi/2, or pi over 2. Once again, don't worry too much about the values within the parentheses. Just notice how we are using the math class to refer to pi. Next, we'll set sine 270 equal to 3pi/2, or 3 pi over 2. If we print these values out to the console, we can see we get 1 and -1, which are the correct values of the expressions we evaluated. Next, we will try an example of a logarithmic function using the math class. For this, we will evaluate the log of 10 and print it out to the console. We can perform this evaluation by using the method log10 within the math class. If we run this program, we get the value 1, which if you know about logarithms, you know that log 10 is 1. Next, we'll try out the method that helps in calculating exponential values. For this example, we will be evaluating 10 to the 6th power. Again, instead of typing out 10 times 10 times 10 times 10 times 10 times 10, we can use the method POW from the math class. The method takes two parameters, the first being the base and the second being the exponent. Here the base is 10 and the exponent will be 6. And by including the expression in a print line statement and running the program, we could see we get the correct value of 1 million. A useful application to practice using the math class would be one that can calculate the length of the hypotenuse of a right triangle, given the length of the two legs. Now, if you know the Pythagorean theorem, you know that a squared plus b squared equals c squared. What we can do is create a small program that allows us to input the length of two legs and then performs the calculation to provide the length of the hypotenuse. To do this, we'll create three double variables to store the three values we will be working with. Leg 1, leg 2, and the hypotenuse we'll call hypot. Remember, we accept user input through scanner objects, so we will go ahead and create one called input, and we'll go ahead and hover over this, and we'll go ahead and include the scanner class. Next, we will prompt the user to input the size of the legs one by one. Now notice we are referring to the next double method through the input object. Next double is a method, as is POW. However, notice how POW is not called through an object as next double is. Specifically, next double is being called through the scanner object we named input. The ability of POW being able to be utilized directly from the math class instead of through an object or instance of a class is exactly what makes it a static method. Okay, now let's copy this code and change it up to accept and store a value for leg 2. Next, we will set our hypot value by using the math class and the Pythagorean theorem, which if we know that c squared is equal to a squared plus b squared, we know that c is equal to the square root of a squared plus b squared, which we can calculate by using the square root method from the math class along with the POW method. Pay attention to the parentheses and make sure they are all in the correct positions. After the value of hypot has been evaluated, we could print it out to the console. Now let's run the program. We're prompted to enter leg 1, we will put 3. For leg 2, we'll put 4. And as you can see, our hypotenuse is calculated to a value of 5.